got the gun.
Oh, sure. You just take off your little mask and show us all who you really are. Hmm?
Let her go.
Very poor choice of words.
Let's not do that again.
What the heck? There's no way they could survive that fall. We gotta see this bit again. I don't think it would actually happen like that, but let's see how things will play out.
Okay, so the first error we've encountered from watching the movie clip is Batman and Rachel slide down the 10-meter incline. When the incline ends, they start a 105-meter freefall and crash land on a parked car with no signs of injuries. When the second error we've encountered is that it took too long for them to fall off the building. With a few calculations, we've concluded that the fall should have taken 3.5 seconds rather than the 11-second freefall. The idea that time being an issue derives from an Excel spreadsheet that we've created. We have set up an Excel spreadsheet to find Batman and Rachel's acceleration, velocity, force of drag, and height. We've also created two scenarios, one being the surface area of Batman and Rachel modeled as a circle, and another showing their surface area as Batman, aka Bruce Wayne's rectangular dimensions. To determine what actually should have happened in that scene, we split our scene into two different parts. First, we will analyze the scene where they slide down the incline. Then we'd look at the freefall scene separately. After we analyze both, we can input the final velocity of the slide as initial velocity for the freefall. But before we could do any calculations for the incline, we first must set up an energy problem. And as stated earlier, we will use an Excel spreadsheet to model the freefall. With a bit of research, we find that they fall from the Illinois Center building, which is approximately 110 meters tall. We estimate that the roof incline would be 10 meters long, which means that they fall 5 meters from the Y direction. And that means that Batman and Rachel fall for 105 meters. We find out that Christian Bale is about 90 kilograms and Rachel about 60, which that can add up to 150. The car model that they land on is a Ford Crown Victoria, which means that their final height to be like about 0.6 meters. And obviously the surface they slide on in the beginning was glass.
When beginning any sort of calculation, we have to look at the variables that we're using in order to see and get an idea of where we're even starting with anything. So on our incline roof, the first two variables that we needed to discuss about was the height of both Batman and Rachel. Batman, played by Christian Bale. Online you can look that his height is 1.83 meters, and Maggie Gyllenhaal, who plays Rachel, is 1.75 meters. As they were falling down the incline, they both had their arms stretched out for each other. This is about 4.78 meters, which is the sum of both of their heights stretched out towards each other. They slid for around 7 seconds, so we estimated that at that length of the both of their bodies, this would create the hypotenuse length of the incline to be around 9.56 meters. We rounded up on this number since it's hard to get exact numbers with camera changes and video edits and stuff like that during an action scene, but we felt pretty confident that we came to a very close number for what the actual length and time is. So since there are assumptions made during this, we're going to list those out now. It would be pretty difficult to precisely calculate them tumbling through the air in a very, abstract matter, no kind of rhyme or reason to it. So we combined their masses into a couple different shapes. So the first one we did was putting their masses into a spherical type shape, and then one into more of like a rectangular shape, which is kind of how Batman is shaped in himself. Also, for the masses of both of these people, we're just going off of what we could find about them personally, and not anything that has to do with the movie at all. Just Christian Bale and Maggie Gyllenhaal. That's who they are. That's their masses. Also, we're not taking any of Batman's armor into protection. This is because when falling that high, it's not going to really matter wearing a piece of armor or not. You're still going to feel those forces through that. Also, lastly, we're just going to assume that they were at 0 when they started down this incline. It would be hard to get any kind of number or distance for when they were moving beforehand down this incline, since it was such a quick little, flash of a scene that we would get before that. This also kind of gives them a piece of credit to actually being able to survive this fall, since we're giving them less initial velocity in that direction.
In order to calculate the final velocity of the moment before impact, we must first find the initial velocity of the free fall. This means we need to look at the inclined roof and set up an energy problem. First, we know the energy initial is equal to the energy final. We know that there is potential energy of gravitation at the beginning, and we assume no initial velocity. Therefore, initial kinetic energy is 0. Next, we move on to the other side of the equation, where we know that there is final kinetic energy, work due to friction, and gravitational potential energy. We plug in the equations and solve for velocity. For normal force, we use the F-net equation in the y direction, and we plug that in order to solve. We obtain a value of 9.44 meters per second. Next, we move on to our Excel spreadsheet, where we can input this value as our initial velocity. We also input an initial height of 105 meters. We have a rho value of 1.2, a drag coefficient of 0.9. We model our heroes with the smallest possible surface area, and they hit the car at around 3.6 seconds with a velocity of around negative 50 meters per second, or about negative 112 miles per hour. However, we want to be more accurate with our surface area, so we move on to a rectangular model. We model a rectangle with a height of 1.83 meters, the height of Batman, and an estimated width of 0.75 meters. We obtain a rectangle of 1.3725 square meters, and this means we get a velocity of negative 98.6 meters per second, hitting the car at around 2.9 seconds. However, we must look at terminal velocity. Because of the large surface area, terminal velocity is likely to be small enough to be an issue. Therefore, we can calculate it as the square root of 2 times mass times gravity divided by rho times surface area times the drag coefficient. With the values from before, we can calculate a terminal velocity of negative 44 meters per second, or about 98 miles per hour. This means that our model of them hitting the car at 2.9 seconds is inaccurate, because the model assumes that they can keep accelerating. What we do know is that they hit this speed at around 2.04 seconds after beginning their freefall. Another interesting point is that they will likely pass out from the opposing forces.
So basically, what we've come across here is one of the biggest issues in this whole scenario is why can't we determine an answer on exactly how much force it's needed to basically kill a human being falling from that distance. So after doing some researches and stuff like that on articles and some websites, no scientists or doctors have mentioned any guaranteed numbers on how much force it would be needed to kill someone. And this is said because after doing some research, there has been many cases reporting miracles or luck, depending on people's beliefs, of people surviving great heights. This all really depends on the person. Not necessarily depends on every scenario at the same time, because I did read that there was a 102-year-old lady who fell 4 stories and survived. And you would think that someone that's that old and, her whole body just aged so much, you would think that anything could honestly just kill her, or do very, very serious damage. But as of the article, the lady was hurt a little bit, but she didn't really sustain big injuries. Another thing that I did read was that there was this 20-year-old, I think it was in his mid-20s. He fell from basically his balcony on the first floor, and he was in a coma, and he passed away during his coma. So that did influence him a lot. So it does depend. It doesn't necessarily mean how old you have to be, or the height. It all honestly depends. That's why scientists or doctors haven't really given us a specific number. And the one thing that I do want to bring up here is the most famous case, which is by Vesna Vulovic, which she is from Yugoslavia. She was a Serbian flight attendant. She currently holds the Guinness World Record for surviving the highest fall without a parachute, which is a record of 33,330 feet. The whole thing happened was when an explosion tore through the baggage compartment of a flight she was on, back in in the 1970s. The plane crashed in Czechoslovakia, and what happened basically, she just flew out of the baggage compartment and free-falled all the way to the ground. And what it says on the article, and that's why she won the record, she did not die. She did spend days in a coma and was hospitalized for several months. She suffered a fractured skull, 3 broken vertebrae, 2 broken legs, etc., etc. But we do see here that falling from an airplane all the way up in the sky did not kill her, which just kind of proves back to the main point, where no scientists or doctors have really, can really mention anything like that, because you would think that falling from that big of a height would just kill you the second you hit the ground. But in this case, we did not see that. That's why it's really hard to come up with a number for that. But in conclusion, whether we want to look at it in the longevity of the drop or just the force of the fall, we clearly see that in this movie there is really bad physics in play here. Even if it's Batman, because he's so great, we are still trying to apply some real life scenarios here to get the most out of it. And if we were to see the result of a real life scenario happen in this movie, regardless of the armor and the cape Batman has with him, there would be no more Batman to protect Gotham City, due to him basically just plowing through his death at the very end, since it seems like a very impossible thing to do.